Now we're going to talk about dividing common bases with exponents, negative exponents, and exponents of 0. When I'm dividing common bases with exponents, the basic rule is that you subtract the exponents. There's a couple ways we can do this. I can do the expanded way, which can take a long time, especially if you've got x to the 49th power or x to the 100th power. If I have x to the 5th, I multiply x by itself 5 times over x to the 2nd, which is x times x, 2 x's in the denominator. Now I can divide out common factors of x. Every time I divide out a common factor of x, I'm left with 1. So 1 times 1 times x times x times x in the numerator equals x to the 3rd in the numerator, all over 1 in the denominator, which we can just write as x to the 3rd. The second way I can show you is when we have common bases, we subtract the exponents. So it's x to the 5th power minus the 2nd power also equals x to the 3rd power. Now the way that I really like to do this is to the way I really like to do this is if I write x to the 5th power over x to the 2nd power, I like to cancel out and divide right there in the fraction. This really helps us with more complex fractions that'll be coming up later on in the semester. So I look at both the numerator and denominator and decide what is the greatest amount of x's I can take out of both the numerator and the denominator. I can divide out x squared. So when I divide x squared by x squared, I'm left with 1. When I divide x to the 5th by x squared, I'm left with 3 x's. So x to the 3rd. So now what I'm really left with is x to the 3rd over 1, which simplifies to x to the 3rd. All right, so now we can try that actually with variable terms. When I've got a coefficient, basically your coefficients are like one problem and your variables are like another. Now again, I can show you these in 3 ways. The best way for the future, in my mind, is the way I'm going to show you in blue. So if I have something like 10m to the 4th over 15m, I can divide a common factor of 5 out of both 10 and 5. When I divide 10 by 5, I'm left with 2. When I divide 15 by 5, I'm left with 3. Now, in terms of the variables, I can divide a common factor of m out of the numerator, and then I'm left with m to the 3rd. If I divide m by m, I'm left with 1. So my answer in the numerator is 2m to the 3rd power all over 3. Write that a little clearer. 2m to the 3rd power all over 3. All right, now you try the next one. All right, now we can divide a factor of 3 out of the numerator, and I'm left with 1, and 3 out of 18, and I'm left with 6. Next, I can divide 2 x's out of the numerator and denominator. In the denominator, I'm left with 1. In the numerator, I'm left with x to the 3rd. This leaves me with x to the 3rd power over 6. All right. Now, If you look at my PowerPoint, there's another way we can expand it and then divide out our common factors. Like I said, if you get something like m to the 49th power, that's a lot of m's to write. I can also divide by the 3, and I can do the shortcut by subtracting. I can reduce the fraction. Either way, we get to the same answer. All right, going back through the rules of common bases. When I multiply common bases, the shortcut is to really add the exponents. When I'm dividing common bases, the shortcut is to really subtract. Regardless of what you do, whether you expand the expression out or use the shortcut, the answer will be the same. The shortcut just gets you to the point quicker. All right, so now I'm going to start to simplify. If I divide x to the third out of the numerator, I'm left with x to the fourth. And if I divide x to the third in the denominator, I'm left with 1. Altogether, I get x to the fourth. All right, now try the next two and pause the recording. Okay, now check your work. I can divide out y to the 11th, and I'm left with the 8th power over 1, which is y to the 8th. I can divide a common m out. I'm left with Remember, when variables are next to each other, that means multiplication, so I don't need to rewrite the multiplication sign. Remember, I can just subtract 3 minus 1, and I get 4 minus 1, and I get the new exponent of 3. Check your work. And remember, when I get this t to the 0, because I'm dividing that out, that also equals 1. That's another way to get there. Negative exponents mean inverses or reciprocals. So if I have x to the negative 1, not quite sure what's going on there. Let me escape for a minute. If I have x to the negative 1, Not quite sure what happened there. The reciprocal of x is 1 over x, is x over 1. So the reciprocal would be 1 over x. Now if I have a exponent there, 1 over x, I'm dropping x into the denominator, and my exponent comes down as a positive exponent. So that's 1 over x to the first power. Now let's look at the next one. So if I drop my 3, because that's the base, into the denominator. The negative exponent actually implies that it's a fractional amount. It's not a negative number, it's a fractional amount. Remember, it's the reciprocal of x. So I'm dropping my base into the denominator. I take it to the first power because I have an exponent of 1, and I put a 1 in the numerator. And that equals 1/3. Okay, same thing on number 2. I drop it into the denominator to the first power. I put it over 1 because the reciprocal of 5 is 1 over 5. Now, when you have an exponent of -2, again, remember, you drop the base to the denominator, and I take the positive exponent of -2, 2. Once I put it in fraction form, I lose the negative exponent. It becomes a positive. And again, the reciprocal of 4 is 1/4. Okay? Now we can simplify this further to 1 over 16. That's a reasonable number that we would expect you to simplify it. All right, now stop the recording and you try the next couple. Okay. Now fractions may be a bit tricky. Remember, with a negative reciprocal, they're both to the first power, only I'm taking the negative exponent, I'm taking the reciprocal. So it's 5 over 4 to the positive 1 power. To the positive 1 power. So that equals just 5/4. 5 to the first power, 4 to the first power. Now try the next one. Now check your work. Going to take the reciprocal of 2/3. And take them both to the second power. 3 to the second power over 2 to the second power, which makes 9 over 4. There's your answer. All right, let's follow the pattern. When I have 3 to the third, that means 3 times 3 times 3. 3 to the second really means 3 times 3. Every time I'm dividing by 1/3. If I divide a 3 out, I'm left with 1 less 3, 3 to the first power. So if I have 3 to the first power equals 3, if I divide it by 1 more 3, on the right-hand side, that's going to equal 1. But if I continue the pattern, it's going to be 3 to the 0 power. And that is still equal to 1. Now remember, if I divide that 1 by 3, I get 1/3. Or 3 to the -1 really means 1/3. And I divide it by another, it's 1 over 3 times 3. 1/3 times 1/3. So take a minute, look at that pattern. 3 to the 0 power. A couple ways we can look at it. Every time, we're also always multiplying by 1. So when I get rid of all my 3's, I'm left with the first power, 1. I can use my rule of subtraction. I can use my fraction, multiply it out. But regardless of what you do, actually let's go back. I want to show you one third way. If I like this one. If I have x, say I have x to the third over x to the third. I multiply that out. This means x times x times x. Over x times x times x. When I divide these common factors of x out, I'm always left with these common with the 1, which equals 1. Another way to do that is x to the third minus the third power also equals x to the 0, which equals 1. So another couple ways to look at that. The basic rule to remember is that anything to the 0 power is equal to 1. Alright, so now let's try some practice problems. Why don't you do number 1 on your own? Alright. I'm going to turn it into a fraction. My x is the base. I drop it into the denominator. Take it to the positive fifth. Now, number 2 is a little trickier. So I'm going to do number 2 and 3 with you and let you do 4, 5, and 6. The base of the exponent, -3, is what it's touching. And it's only touching the y. So when I drop down into my denominator is the y, because that's the only base of that exponent. And the 5 still stays in the numerator. That's like saying 5 over 1 times y to the -3rd power. Remember, y to the negative power is a fractional amount. Now when I'm multiplying it by a parenthesis, what's touching the exponent is the parenthesis. So everything in the parenthesis is dropped down to the second power. Notice I'm taking the positive exponent and the 3m drop down into the denominator. Okay, I can simplify that further. 1 over 9m squared. Now pause it and do the next 3 problems. Okay, now check your work. And that's the last part of the lesson. Now rip it up on your homework.